Hello everyone and welcome back to the course. In today's lesson, we are going to learn a new chapter, a chapter on exponential and logarithmic functions. And the best way to start this chapter is by learning the concept of sequences. A sequence is a function f which is defined from the set of all natural numbers to the set of all real numbers, which takes a natural number and it assigns it to a value a sub n, which represents a real number. Examples of sequences are the following. The one given by f of n equals 2 times n. The one given by 5 to the n. The one given by 1, 1, 2, 3, 5, 8, and so on, where the next number is gotten from adding up the two previous numbers. And of course, the sequence of prime numbers. Now, there are two particular types of sequences that we are going to check on this lesson: arithmetic sequences and geometric sequences. We say that a sequence is arithmetic if its consecutive differences are constant. And we say that a sequence is geometric if its consecutive ratios are constant. Let us take the sequence 2, 4, 6, 8, 10, and so on. If we take the first two elements of the sequence, 2 and 4, and we do 4 minus 2, we get 2. If we take 6 and 4 and we do 6 minus 4, we get 2. If we do 8 minus 6, we get 2. So all of the differences are constant. Therefore, this is an arithmetic sequence. Another example is a sequence given by 3, 7, 11, 15, and so on. If we take all of the consecutive differences, we get the constant value 4. Therefore, this is an arithmetic sequence. Now, all of the arithmetic sequences can be represented as a linear function of the type f of n equals a times n plus b, where a and b are constants. For example, if we take the arithmetic sequence 3, 7, 11, 15, and so on, we notice that there's a constant that appears in every consecutive difference, which is the constant value 4. Therefore, the equation for this sequence is f of n equals 4n plus b. Now, this sequence is such that f of 1 is equal 3. So we can use this point in order to find out the value of b. Now we can do that 3 is equal to 4 times 1 plus b. Therefore, 3 is equal to 4 plus b. And when we solve for b, we get that b is equal to -1. Thus, the equation that represents this particular sequence is given by 4n minus 1. Now, let us take into account the sequence given by 3, 9, 27, 81, and so on. If we take all of the consecutive ratios, we get the constant value 3. Thus, this sequence is geometric. Now, if we take the sequence expressed by 4, 20, 100, 500, 2500, and so on, then if we take all of the consecutive ratios, we get the constant value of 5. Therefore, this is also a geometric sequence. All of the geometric sequences can be expressed as an exponential function of the type f of n equals a times b to the n, where a and b are constant values. For example, if we take the sequence given by 4, 20, 100, 500, and so on, we know that the constant ratio here is 5. Therefore, the value of b is equal 5. So our equation is now f of n equals a times 5 to the n. In order to find the value of a, we have to use the information given. We know that f of 1 is equal 4. So 4 is equal to a times 5 to the 1. And if we solve for a, we get that a is equal to 4 over 5. Thus, the equation for such a geometric sequence is given by f of n equals to 4 over 5 times 5 to the n. Well guys, that's it for today. Thank you very much for following this video until the very end. Now it is your time to take over. Try to solve the following problems. The idea is to be able to identify if a sequence is arithmetic or geometric. Try to also provide an equation that can give you the general term. And as usual, see you in the next video.